Hello and welcome back to the breadboarding tutorial series. In the previous video, we learned how to heat shrink and created a T6 sensor that was ready to go into our circuit. In this video, we're going to be building the final circuit combining the PT1000, Tsic and Dallas together to create one big circuit. So before we begin, quickly to note that this is not the final circuit. There is still the solar panel, which is optional, but is a good idea to try and incorporate into your circuit because it allows for independent powering of the circuit. Now that we've got that out of the way, let's continue on with the video. Before we actually begin building the circuit, I think it would be worthwhile drawing out the circuit diagram so that we can understand what it is we're actually building. If you do not want to see the circuit diagram, feel free to skip forward in the video to actually building the circuit. We're going to begin, we're going to draw our Arduino. I'm just going to draw it as a simple box just now, as I don't want to put all the detail into drawing an actual Arduino board. So I'll just label it as ARD for Arduino. Next, we want to take our 5-volt rail from our Arduino. Note that this isn't actually where it appears on the board, it's just to show that we have a connection coming from it. We're going to drag this along, so we imagine that now we're on the breadboard, we are creating our 5-volt rail across the top. We are going to connect each sensor circuit in parallel, so I'm going to draw 3 junctions on our 5-volt rail here. The first one that we're going to connect is going to be the PT1000. So, as we covered in our previous video on the PT1000, we require a voltage divider. We start with one resistor, and then we connect our thermistor, the PT1000, in series with this. What we have to do to be able to take a reading from our PT1000 is feed off one wire from in between these two resistors here, and then we plug that into our Arduino on our analog pin. I'm just going to call it A5. This is actually going to be the pin that I connect it to, but you can choose any of the analog pins that you wish. Then at the bottom, we have to bring out our 0-volt rail. Again, just like the 5-volt rail, I'm going to draw this to come along the bottom, and I'm going to draw our 3 junctions once again. Here's our 0-volt line. And this is the first part of the circuit. The second part, we're going to connect the Tsic. Again, I'm going to draw the Tsic just as a box, and I'm going to label it T. It's not that important that I've labelled it, but it's easier to see what's going on. Then we will connect our Tsic to ground as well. And again, to be able to read from the Tsic, we have to have a third wire coming off. I'm going to bring this down here and out the way. And this is going to go into one of the digital pins. I'll just write dig. Thirdly, we now need our Dallas. If you remember, the Dallas requires a pull-up resistor between the 5-volt line and the COM line. We're going to have to put this into our circuit. So I'm just going to label our Dallas DS, and then we're going to have 5 volts and 0 volts connected. To be able to connect our resistor, what we want to do, we'll have to put in another junction, split it off from here. This here goes as a resistor, which connects on to our COM port. Then, again, to bring it out of the way, I will bring this up and along, and then connecting also into our Arduino board. I will also label this dig. You can choose any of the digital ports on your Arduino board as long as you know which one it is that you have put each sensor into. If you do not know which one it is, you'll have a hard time creating your Arduino code. Now that we know what it is that we're going to be building, we should move over to actually creating the circuit. So I'm going to move this paper out of the way, and I'm going to keep this next to me as a trusty reminder of what it is that we're actually building. I'm going to bring over our Arduino and our breadboard, and what I've done off camera is I have cut wires to size to save some time. When you're creating your circuit, it's important to make sure that your wires are as small as they need to be, so that way that it keeps your circuit nice and neat and compact to the board. We'll begin by connecting our 5-volt power line here from our Arduino. So we plug into the 5 volts, and I'm going to make my 5V rail port column 1. Next, what I'm going to do is I'm going to begin by connecting the circuit for our PT1000. Since column 1 has now got 5V going into it, I'm going to connect our resistor for our PT1000 into columns 1 and column 5. Notice how with a normal resistor, I have one here as a demonstration. Before you cut them, they are quite long and they would stick quite far out the board. What I've done is I've cut the legs of the resistor to make it nice and short and keeps it very close to the board. Second, what we're going to be doing is we're going to take our PT1000, which I have in fact also heat shrunk and then on the inside, and put our larger tubing around as we covered in the previous one. I'm going to connect our PT1000 into columns 5 and columns 9. And this is setting up to create column 9 as our 0V rail. The PT1000 is currently sitting quite close to the camera, so I'm just going to bend it over away to the side so you can still see what's actually happening on the board. Next, as I mentioned, we have to have a comm line. The comm line I'm going to use is going to be our yellow wires, and we have to connect this on the same column that our two resistors are connected into. So this is column 5, and as I said, I'm going to plug this into analog pin 5 on the Arduino. Next, I'm going to connect the Tsic. The Tsic, we have our red, our green as our 5 and 0V respectively, and again yellow for data. I'm going to connect the Tsic into columns 1, column 6, and column 9. Notice how this is in parallel with our PT1000 as we drew in our diagram. This means that they will both get the same voltage as we've covered before. Once again, I'm just going to bend the sensor out of the way so you can still see the circuit. What we have to do as well with this is we have to add our COM ports once again. Since I've used column 6 for the Tsic, I'll plug our COM ports into column 6, and I'm going to bring this over to digital port number 9, as so. Now we have two of our sensors connected. We'll finish off with the Dallas. Once again, this has been heat shrunk off camera, but I did exactly the same as we covered in the previous video. I'm going to connect our Dallas into columns 1, column 7, and column 9. There we go. Now I'm going to move the legs of these ones up just because we still have the pull-up resistor to plug in for the Dallas. So again, I'll bend the sensor out of the way. And here is our pull-up resistor. I'm going to plug this resistor into columns 1 and 7. And it should fit quite snugly if I've done this correctly. It can be a little bit awkward to push in, but there we go, we've got it in. Next, we have to connect our COM ports once again, and since we use column 7, you've heard it before, we'll use column 7, and I'm going to use digital pin number 8. Just have to move this out of the way. And there we go. Now, no circuit is complete without being able to bring it back to ground. So since we've got all of our grounds for our sensors in column 9, we'll bring one wire from column 9 into the ground on our Arduino. So we will slot that into our board, and that is our final circuit. As you can see, we've got everything quite neat, and we've used very few wires. In fact, we've used the minimal amount of wires that we needed to make our circuit. Of course, if you were using the other Tsic code, which requires you to name the voltage pin for the Tsic, you would have had to connect one more wire over to a digital pin. But that's everything for this circuit, and we will have to change it ever so slightly for adding our solar panel, especially if we want to be able to read what voltage our solar panel is supplying. However, that is for next video, because this one is now coming to a close. As always, thanks for watching, and I'll see you in the next one. Bye for now.